Hey guys, so we've studied lots of functions in Algebra 2, and the last type of function that we're going to study in Algebra 2 is called a rational function. But we're going to start with rational expressions and what they are. So if you recall from the very beginning of the year, when we looked at different types of numbers, we had said that rational numbers are numbers that can be written as a fraction, right? So for example, 1/3, 5/9, 2 because 2 is 2/1, -7/2, all of those are rational numbers, so any number that can be written as a fraction. Similarly, rational expressions are just expressions that can be written as a fraction where the numerator and denominator are polynomials. So we spent the last 2 weeks looking at what polynomials are, right? X squared plus 2x, that's a polynomial. X cubed plus 3x minus 4, that's a polynomial. So rational expressions are just algebraic fractions where the numerator and denominator, instead of being just numbers, are going to be algebraic expressions. Numerator and denominator are polynomials, and here are 2 examples shown. And if we want to simplify rational expressions, we simplify it just like how we simplify normal fractions. So let's start by looking at something that you're familiar with. If I ask you to simplify 15/40, you might say, well, okay, I can reduce it, right? I can divide both by 5. And essentially what you're doing is you're saying, all right, 15 is the same as 5 times 3. So I'm going to rewrite the 15 as 5 times 3. And then 40 is the same as 5 times 8, right? And when you say divide both by 5, essentially what you're doing is we are dividing 5 by 5, which 5 divided by 5 is 1, so we can cancel out a common factor if it's in the numerator and denominator, and our reduced fraction becomes 3/8. So the same rule applies, canceling out any common factors that are in the numerator and denominator, because when you have 5 in the numerator and 5 in the denominator, it just divides out to 1. So the same rule applies in rational expressions as well, except sometimes you have to factor. So in B, we have 4x squared minus 2x divided by 2x. And the first thing I'm going to do is see if I can factor completely the numerator, and then factor completely the denominator, if I can. So in the numerator, remember our first rule of factoring is there a greatest common factor that I can divide out from every single term? So I'm going to leave the denominator alone and just work with the numerator first. The GCF in the numerator is 2x. And if I divide out a 2x, I'm left with 2x. 4x squared divided by 2x is 2x. And then negative 2x divided by 2x is just -1. Okay, dividing out a 2x, which becomes a factor. And the other factor is 2x minus 1. And then in the denominator, they are already factors, 2x. Okay, so what can I cancel out? Well, I have a 2x in the numerator and a 2x in the denominator. I can divide them out. They divide out to 1, so I'm going to cross them out. And my final simplified expression is just 2x minus 1. And that's it. So let's go over some steps to simplify rational expressions. Number 1, you're going to factor the numerator and denominator completely. And then number 2, you're going to cross out any factors that are both in the numerator and denominator. So common factors that are both in the numerator and denominator. One thing to note is that your factors have to be multiplied by each other. Okay, there cannot be any pluses or minus in between your factors. If it's x plus 4, that's one factor. You can't break up the x and the plus 4. So can't break up any pluses or minuses. Alright, so let's try another example. We have x squared plus 5x plus 4 in the numerator, and x squared minus 16 in the denominator, and the first step is we're going to try to factor the numerator first. Okay, so let's go ahead and do that. I have a quadratic, so you could use x factor method, or you could use guess and check if you want. You want factors that multiply to give you a times c, so that's 4, and add to give you 5. right? So that would be 4 and 1. So I'm going to rewrite this as x plus 4 and x plus 1. This is my numerator in factored form. And then I'm going to go ahead and factor my denominator. So for my denominator, I want factors that multiply to give me negative 16 and add to give me 0x in the middle. So that's going to be negative 4 and positive 4. So I'm going to factor the denominator as x plus 4 and x minus 4. Okay, so notice that each factor has a parentheses, and we're going to cross out any common factors. So in this case, I have x plus 4 and x plus 4 in common from the numerator and denominator. I'm going to cross them out, and my final answer is x plus 1 over x minus 4. So right here, this is it. I know you're really tempted to say, well, don't I have an x here and an x here and I can cross it out? The answer is no, because this x is attached to the plus 1 on the top, and the x on the bottom is attached to the x minus 4. Okay, x on the bottom is attached to minus 4. So you can't cancel out just one term without canceling out the whole factor. So this is it. And this is as much as I can simplify, and that's my final answer. Let's look at the second one. I'm going to again go ahead and factor the numerator. And if you want to pause, you might want to pause and try it on your own, and then check your answer. So this one I'm going to just factor x squared plus 6x plus 9. I'm going to factor into x plus 3 and x plus 3. Okay, and then my second factor, my denominator that I'm going to factor is a little bit trickier because my denominator has a leading coefficient that is greater than 1. So I'm going to do it down here. I want factors of a times c, so that's 2 times negative 3 is negative 6 and adds to give me 5. Okay, so my two factors that multiply to give me negative 6 and add to give me 5 is 6 and negative 1, and that's how I'm going to split up the middle term. I'm going to rewrite this as 2x squared, and then we're going to break up the 5x into negative 6x minus 1x, and then we're going to factor by grouping. So GCF from the first group, a little refresher what we did last week, right? I've got 2x times x minus 3, and then GCF from the second group, negative 1, and I'm left with x. There should be a plus 6 over here. So x plus 3. And dividing out a negative 1, I have x plus 3 as well. So from both of these groups, I have x plus 3 in common. So I'm going to take that out. And I'm left with 2x minus 1. So those are my two factors. I'll write it over here, x plus 3. And ding, 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 that's a common factor that I see, so that's a good sign, right? And 2x minus 1. So now I'm going to cancel out and cross out my common factors. X plus 3 divided by x plus 3 just turns into 1. The other x plus 3, I don't have anything else to cross it out with, so that is just it. My final answer is x plus 3 divided by 2x minus 1. Remember, these x plus 3 is one factor and 2x minus 1 is one factor, so you can't cross out the individual terms. And that's it. If you factored and there's nothing you can cross out, then your rational expression is already simplified and you can't simplify any further.